Okay, let's hope that works. So we'll be logging in to the Jeremy box. Now, when we log in, what you're going to notice is this login thingy is going to change. Okay, so SSH, then you use your username. Don't use mine, it won't work for you. Okay. So whatever your first part of your email, your first name, 6 digits, whatever, and then hit enter. Yeah.
Is the first digit of the name capitalized?
No, your name should all be lowercase. Thank you. I make all kinds of mistakes. I don't feel bad about calling me out on something stupid. I make all kinds of dumb mistakes. Okay. All right. And you log in. Oops. Key exchange. That means I have to do something else. Okay. Now you notice mine did magic. Poof. It logged in, didn't ask for a password or anything. So what I'm going to do is log out. Control D, or the word exit. So remember, we keep having these little commands that we use that you do during class and you forget about until the next class, and you're going, oh darn, I should have written that down. Okay. So Control D for exit. Lowercase. And that will get you out of a terminal session. So I created a new user. His name is Chuck. Chuck, spelled this way, is the mascot for the FreeBSD, NetBSD, and OpenBSD. He's a little devil with horns. Actually, he's not. He's a Damien. He's not really a demon. He's a Damien. Okay. Lots of funny folklore there. Then you log in and notice your prompt will change. This SSH will work on your Windows box. It'll work on your Mac box, and it'll work on a Linux box. This is one of the few commands that actually works across all platforms. And then once you get to that part, it says password. Hold on, we're right there. You do have to type in the word yes. The very first time you'll type the word yes. Okay. And then the password is uppercase L, uppercase R, 2, 3, 1. Linux rocks. Okay. ROX. And once you're logged in, you should be able to do LS and all that sort of thing. Now you can use the Jupyter Notebook. I'll show you that in a second. So this will work for you. So you can do that if you want. That's just the next step. Yeah, just hit up our move again. Yeah, we're getting some timeout errors. That was my goof. I was playing around with networking on my virtual machine, and I think I messed up something. So we'll see how it works tonight.
Linux rocks. ROX.
LINUX ROX 231. Linux rocks. As in this classroom 231. Okay. Now, once we get here, first thing I want you to do is an LS. You should see a bunch of directories that are already created for you. When you install a Debian Fresh or a SUSE Fresh or a Linux Fresh, and you add a user, you will not have those. I've customized the add user program to give you certain things, in these directories. Because this is this server box I take care of for the classes I teach. Okay.
So my connection is closed.
You can yell,
It says my connection is closed.
hit up arrow and try again. I'll have to fix that tonight. I think I know what I did.
And then when I type my password, it's invisible.
Yes. On Linux, the login prompt, you put in your name, right? Password does not return a star. Nothing gets returned. In the world of web dev, it's not that hard to create a shim and capture everybody's traffic. If I set up Kali Linux and I set up a man in the middle, and you log into the bank, you log out of the bank, I capture that entire encrypted stream. I take that encrypted stream, run it through a few nefarious tools. I have your password. Can't do that here because nothing comes back to the user. But if the user has a keylogger, well, guess what? The keys have been detected. Okay. All right. So when you log in, do you have an ASM directory? When you log into the Jeremy box?
Yes.
There is one. What's in there? Is there anything in it? Do ls space ASM. Exit data. That's the only thing that's in there. Okay. All right. Now, if you've had the Linux class, this part's easy. Okay. If you haven't had Linux, you're lost. And it's all going. Okay. All right. Now, what we have is I want to show you a few things to begin with. Did everybody get logged in? Let's start there. Anybody need help? Anybody need miracles? Is it not working through the? Permission denied. Now can you log in from here? So say type in yes. Let's make sure your user is created. So there's a couple ways to do this, but this is the way I do it. I just do an ls on. So is your name up here? Is that you?
Yeah, so I'm putting a 0.
Oh, okay, you're using the leading 0. Okay. Yeah, now everything should work. So if your name does not appear, let me know and I'll add you. Is your name missing?
Yes. Yes.
It's missing.
Yes, it's not.
Where's the roll sheet? Just sign in. So your login's not up there? Did you add it to class?
Yeah, I did.
Always there.
Let's do this.
We found it.
Oh, okay. I was gonna say, look at this and see if I got your name on here.
How did you do it?
Because this is the roll sheet. So you're there. Now that we passed census, all I do is check roll this way. And this is my fudge factor, letter grade difference type thing. If you need a few steps. All right. Now, we will not need a lot of Unix commands in this class, but there's a few you're going to have to know. Okay. And we'll start with the ones you'll need to know. PWD, and then CD, and LS. Those are the ones you actually have to really start with. And you can run those at any time and in any order. And if I say CD space SQL, you can see what I have there. And then if you type CD all by itself, do PWD, and then do CD, and then do PWD again. CD by itself will always take you home. Stands for change directory. All of this stuff you can go learn for free at linuxcommand.org. It's also on the website. You go down here, Linux command line free ebook. Click. There it is. Now, if you get into security, you have to know Linux. There is no option. They would, yeah, you got to know it. And you better learn PowerShell. You can run PowerShell on Ubuntu Linux now. Okay. All right, so we got a very few things there. Now, I'm going to ask you to do some things. Follow my keystrokes. Type in CD, enter. Okay. Now, the next one is CD space ASM. And you have a directory, so let me cheat. Let me make my user look like your user. Okay, I now have an ASM directory, but mine's empty. That's okay. This is the file you have, right?
After CD ASM, you went LS.
Louder.
Yeah. After CD ASM, you hit Command LS, and then what was the
Yeah,
command
you
after
can do that
LS?
and you see what's in there.
Okay.
So what exactly is ASM directory?
ASM?
Yeah, what is it?
Assembler.
Oh,
Short for assembler. That's just my nomenclature. All right. Let's do it that way.
Are we making a new file?
Yeah, kind of, sort of. You are part of the class, and when you say something, everybody in the classroom hears you. So feel free to talk up. Okay.
Sweet.
So they might be able to hear you. Can you hear him? Yeah. So, Tosh, can you hear the classroom?
I can hear the little laughs in the background.
Okay, you can hear laughs. Okay, all right, that's good. All right. So this is the file that we have. We don't have any clue what we're looking at yet. You will know what this is by the end of the semester. This is assembler. Okay. Now, everybody, take your notes. Put your brain on a bookmark. Log off the Jeremy box. Close anything important. Save anything if you think it's that important. 5, 4, 3, 2, 1. Here's a blank piece of paper. Take one down, pass it around.
You're muted. I can't hear you talking, Mr. Phillips.
Yeah, that would make sense. Yeah, thank you. Always look for the simple. Okay, for loop. Oops. And on Linux, you can use a tab key. And notice I hit it twice. And it tells me everything that starts with an uppercase FOR. So I'm going to do the for loop. And then once I make it unique, all I do is hit L or tab and it expands it. So you can use tab expansion. So you don't have to type everything over and over and over again. See? Here's an example of a for loop. This is a good one right here. This is two of them. In Bash, it's for X in whatever, do done. There's no squirrely bracket. Okay. Now, how many programming languages can you think of? How many are there?
Infinite?
Yeah, how many are there? You want to look at some obscure programming languages? This is over 1,500. It's mostly kind of current. There's some new languages out there that aren't up here. So let's take a look at, let's look at Python, one that you probably should know. Because even if you don't code day in and day out, Python will be part of your day job at some point. Let's see here. Let me get this to work right. Here we go. Now, there's a lot of different ways. This is a fun one. Yeah. When Guido, the guy that invented Python, worked at Dropbox, he spent his time training programmers not to be so clever because the next guy won't be able to figure it out. Pretend you're telling a story. So when you write code, you want it to be readable. That makes a lot of sense to me. That's pretty simple to read. And of all the languages I've worked in over the years, Python is the only one I can honestly say I can work in it, do something, set it on the shelf, come back in 6 months and pick up where I left off. I could not do that with C or Perl, let alone Bash. But if you're in them every day, that's a different story. A lot of jobs, you might be doing JavaScript all day long, every day. So your brain never gets sloppy on because you're in it all the time. But if you have to do a bunch of different things, you're going to forget. Okay. So look at this website, 99bottlesofbeer.net. So when a job description says, hey, we need you to learn how to code in D, as in A, B, C, D, you can go at least see what the language looks like and then go read up on it. Okay. And then here's a good one. Everybody loves this one. There's some really weird ones in here, so I give you advanced warning. COBOL, where am I? DOB. The stuff that runs Visa, MasterCard, American Express, and soon to be my Social Security. It's all COBOL. Doesn't that make a lot of sense? When you read COBOL, it's extremely verbose. That's the point. It's a very verbose language to get anything done, but it's extremely picky about where you put the period. Like in JavaScript, if you're running JavaScript and you forget a semicolon somewhere, your code just goes, you get nothing on the screen, nothing. No error code, just blank. Well, at least with COBOL, with no period, it's going to give you a big warning, and it's going to look like your entire code is completely wrong. It gives you way too many errors. Okay.
Dude, the spaces matter. Like, can you do like an extra space by accident and never know and it would mess it up?
In COBOL, the answer to that question is it depends on the legacy code or not. Modern COBOL is not space sensitive. Old COBOL, yes. You had to put it in X number of spaces for this to happen, X number of spaces for that to happen. Yes. There were layout sheets when you wrote out your code. You actually wrote all your code on paper before you typed it in, because there was only 2 terminals and 20 programmers. Okay. The dark ages. All right. Now you know. So go have some fun exploring some languages. And you will see, oh, I guess I should bring up C and C++. Either one of those is fine. Probably C. Let's just do C. There's your for loop in C. Right there. That's pretty common. This for, set it, stop it, increment it or decrement it by is in JavaScript and C++, blah, 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 blah. Almost all your curly brace languages support that at some point. Okay. All right. So, isn't this fun? All right, now back to our assembler. We're going to walk through, log into the Jeremy box again, now that you all know how to do it. And let's see how it all works. And I'll log in as Chuck this time. And one of the commands I use a lot, you'll see me use it, it's called clear. And what that does is it simply clears the screen. It's like CLS and DOS. Okay. So did that. All right. Now, when you do your LS, you have this thing called public HTML. Right? Now, if I type in Anybody in the Linux? What was the year that had the funny on it? 1752? Was that it? Anybody remember from Linux? Yeah, I remember. Yay. Ancient history last Thursday.
What was it? Cal what?
Yep. You type in Cal 1752, hit enter. And in the year 1752, what happened to September 3rd through 13? Where'd it go? Well, that's when they found out leap year was 0.25 of a day, and they changed the calendar to add leap year, leap day once every 4 years. So to get the calendar on the solar cycle, so your summer solstice and the winter solstice would be in the right parts of the calendar, they wiped out half of September. Okay. So what I want you to do now is hit up arrow and do vertical bar LP and hit enter. And then do LS. What happened? Now, this will not work on any distro that you install from scratch. This is my customization. I use the CUPS, which is called the Common Unix Printing Subsystem. And the default printer is a PDF. Like in Windows, you say print to PDF. Well, that's what this does. If you do an LS again, guess what you have? You have a new directory that says uppercase PDF. Do an LS on that uppercase PDF and see what's in there. You can just do it from here, LS space PDF. And it tells you what's in there.
Is Command Cal just calendar?
Pardon?
Command Cal is just calendar?
Yeah, Cal is short for calendar. Vertical bar LP stands for line printer. So you can send things to the line printer. Oh, the password? Linux rocks 231. Oh, it's probably the leader zero. And let me double check to make sure that your username doesn't have a leading zero.
Oh, yeah.
Let's see. Michael. Yeah, there's no leading zero. Sorry about that. It's just this semester that they've gone from 6 to 7 digits in the student ID. So it was 6 digits as long as I can remember until this semester. So that tells me a lot of students are not being obsolesced out of the system. They just keep adding them. So if you came here 20 years ago, your student ID is probably valid. Okay. All right. So if you change directory to PDF and then do an LS and then do file on standard in, it tells you what it is. It's a PDF document. Now we're going to do something we're we won't go too far down this road because this is where I want to take you. Okay. This is where I want to take you. So if let's do this. I'll do cat standard in. Now I will do this so you can see what will happen. Don't follow along. This will mess up your display. Well, that's not too bad. You can do it. This is what a PDF document looks like. Doesn't that look lovely? You can hand roll PDF. It's called PostScript. If you get a job where you're dealing with label printers and you're doing little barcodes, come see me because I can save you a lot of headache because I know that story and I know how to make that stuff work. Done it for years. Okay. It might be PCL5, it might be PostScript, it might be the Zebra printer command, it might be Prescribe. When you send something to the printer actually takes it and turns it into something else before it gets printed. When you send the letter A to the printer, that's all you know. But when it gets to the printer, it changes into something miraculous of nothing more than a bunch of escape sequences that prints the letter A on the printer. Yeah.
Did you just
Awesome.
type display for the code to get that to display, or display the file name, or what'd you do?
I just did cat. I did file to tell me what it is, and then cat to just show me. That's all. Okay. Now where we're going is I want you to open a browser. And type in HTTPS as in secure. And then do jmkll.org. So we're doing this one. Everything in this case, I don't think it matters if it's upper or lowercase, // Guess what? Get to log in again. So use the same username and the same password. This is a web app called the Jupyter Notebook, put on a multi-server head called the Jupyter Hub. Again, this is, you don't care. But now you can click on PDF and you can click on standard. There's your print. So what are we doing? Well, I have created the Jupyter Hub to sit on the Jeremy box that gives you a secondary way to access the system that you are more familiar with, i.e., you can use a mouse. Because in this here, where we go back to launcher, there's this icon that says terminal. What happens when you click on it? You have a web-based terminal that is not dependent on SSH on your machine. If you're running Windows 95, I'm sorry, there's no SSH. There's no Windows SSH on Windows 7 or 8, as far as I know. Does anybody want to know why they went from 8 to 10 and skipped 9? Windows 95 and Windows 98. That's why they skipped Windows 9. That's why they went to 10. Okay. And there's fun things in here. You can change the appearance between light and dark. Or where is it? Edit, view. Anyway, you can have a lot of fun changing this stuff around. Settings, theme, there we go. Let's go with Jupiter Dark. There. So you can play with that. Now, I want to show you the next few steps are going to spare you the anguish and torture of having to learn the VI editor. Okay. So this navigation works a lot like what you're familiar with. It's a little quirky, it's a little different, but basically this means go up a directory. Whoops, that means upload, never mind. So here, I think I click there, that's it. You click on the folder to go up a directory. So we're going to go to this ASM directory, double click, and guess what happens when I double click on the .s? It's in an editor. Blech. Let me say that again, editor. A GUI-based editor where mouse works. Okay. In the Linux class, if you're in the Linux class, you can use this, but don't. You need to learn VI because it will save you a ton of work anyway. Okay. So what we are going to do is repeat what we did with the Simpletron on the Jupyter Hub. You're going to copy the code. You're going to put it into the ASM directory. You're going to compile it. And then we're going to run that first example. Are we ready? Ready, team, go. So where was that? Well, you can open Canvas or just be lazy and go to phillipsd.com/273/labs/site. Hit enter. And we can click right there on the C++ source. Control A. I prefer to use the copy within the browser. Go to Jupyter Lab. Dismiss. And what I want to do is go to my ASM directory. And here I want to put in a new file. What did I do? I right click right under S here, say new file. I'm going to call it simpletron.cpp. This tool will look at the suffix of the file and highlight your code accordingly. Just like cooking with gas. There's our code. Now let's see if we can have all the same problems we did last week. You're gonna have to yell.
Can you show where to get the code from, please?
Oh yeah. The code came from here. 273/labs/site. Scroll down to where it says Simpletron. And it says C++ source. That's what you want. Then you copy it in. And then what do you want to do? Notice the little dot. The little dot says it's not saved. You need to save it. So there's all kinds of ways to save it. Whoops, I don't want to do that. I'll say file save. let's just say save file, Control S. Sound familiar? And then it goes from 0 to X. X means it's saved. Okay. So I don't need to look at this anymore. So I can close that. I don't need my goofy calendar. But here, I need to get to my directory here. And I should be able to do an LS and see my Simpletron. And then if we look at the beginning of our Simpletron, this command head -3 says, give me the top 3 lines. There's a tail that says, give me the bottom 3 lines. So we need to compile it just like we did last time. How many remember the steps? Yeah. The steps are kind of hidden, aren't they? They're in the 3rd line of the file. Those are the commands to compile the Simpletron. And we'll just go up to there. We don't need the other one. Oops, that won't work. I'll just type it in. Simpletron -O Simpletron, hit enter. It worked. No compiler errors. Now let's go over here and go down here to the instructions. So I'm now ready to run it.
I'm just getting my exit .s in the directory, so my Simpletron isn't showing up.
Sure, yeah, that means you probably didn't save it or put it in a different directory. So let's get everybody to the point where they copied the code off the web into a file, saved it, and compiled it. So it's basically the same process. And then if you do an LS, you should see 3 files. Bingo. You're good. Yeah, you don't need a semicolon. Yeah, that doesn't matter. No. Yeah.
You mean
It's basically that saying, if you copy that whole line and then go to your command, which is over there, and you right click paste and you hit enter, it won't do anything because you have // That's a comment. So hit up arrow and remove the // Now hit enter. And now do an LF. Where's your Simpletron? Well, it's not in the right directory then. So what you need to do is move it. So how do you do that? I believe
That's actually
under
that is almost like literally buying like my own shit. You save so much money.
I think what you have to do actually up here, now right click, and then browse.
That's true.
Oh, sure enough. Well, it's in the wrong direction. We need to put it there.
Can I drag it into?
Well, it's not safe. Save. Okay, now close. Now see if you drag it. Yeah. Ah, okay, that works.
Alright, so now.
That's a new update. Now, if you go in
Now
here,
it pops
change-
up in-
now it's there, now you're hit up arrow a couple times, get back to compile line.
CD.
No, you need to be in the ASM directory. CD space ASM. Enter. Now hit up arrow until you get to G++. Just slow down.
Without the back.
You don't need to go, now hit enter. Now do LS, you should have 3 files. Dun, dun. All right, does everybody have 3 files?
So it needs to be in the.
No.
ASM.
Okay, we'll get this working. Okay, it's there.
So what happened? was
Oh,
that
but it needs to be Simpletron.
Oh,
dot
those
set.
Trinity file, what you should have told me to do is
So
open
right
up
click
ASM and then read.
And put CPP.
So- Did it, is it like not showing up for you when you hit LS? Okay, so the,
And now
it's
hit
because it's not in the
enter.
ASM
Now when you
file.
close it,
Your PDF.
so we'll go to the very top.
So it's-
And then you have to change. Highlight. Oh, choose something like on. Copy that. I think, and now go to launcher.
Show in your-
Yeah, and then I just didn't want to see
The 3 files, okay.
And
Make sure it's in the ASM.
so there's your code. Now do the paste. Now do LF. You have all 3 files. Okay, what's happening is
No, I had it when, I created it, when I did it on the ASM. I created it right there.
so just reading. Yeah, it's just the file name needs to be C. There you go. There you go. And now hit Control S. And then your. And now do LF. That's what I think it should be. So it's on.
So I think sometimes, yes, you told me that.
Yeah. I really ain't got shit.
Oh, okay. Should help you out.
All right. Everybody got 3 files, we're ready to do our test.
I made a pretty
To run the Simpletron, you should be able to start punching in your code.
She knows about the computer science, okay.
But yeah, just.
The catalog. I did, I guess, the for the transfers, but I got so much. Oh, okay. I thought you meant you have to have been a transfer student not to take it. Okay. Oh, because technically you transfer. Okay. So. Okay.
There you go. Now we're.
That's like the only thing keeping me alive. It's like,
Yay. Everybody got it?
yeah. Really?
You're gonna have to yell at it.
Sweet. So you already got something? You didn't even look.
Okay, are you logged in? Okay,
Really? I mean,
so click on your head.
he knows stuff. He knows stuff.
Okay, you open up your Simpletron. Go over to the Simpletron. I like that.
The thing is like.
Really good. It's fantastic.
You know, like it's basically.
Well, I see him always here at the meeting.
Rename it Simple Tron. Dot CPP.
He's done some penetration.
Hey, yo.
It's not a lot of people like that. Yeah. Well, that's the cool thing about technology. It's like, it's not about if you can do it, it's if you should.
CD.
Yeah, that's what I don't want to do. It's like,
All right.
yeah,
Now
the
what?
rest of your life. I'm trying to do this.
Island. So look at the code.
Is that a program? And then that's for the hospital. So you use that?
Short play. Simple Tron.
Yes, and like diagnoses and be able to read the code. Some have like codes too.
All right. Mission accomplished. So far, nothing has exploded. This is a good sign. Now, if you type in the Simpletron, you're gonna start, it's gonna prompt you
They don't know.
for
Yeah, they have no clue.
the macro codes. Right? All this fun stuff that is in over here, right? It's a little hard to see. Okay. Your next lab assignment is using the Simpletron to add 3 numbers and the equivalent of a for loop that prints 1 through 10. That means in order for you to achieve this, I will do some more instruction about the Simpletron, which is a pretty easy introduction to assembler. You get the idea of here's a chunk of memory, we're putting something in it, and then we're going to go back to that memory, pull something out of it, and we're going to modify working code to do what we want to do. Okay? So if you've gone through these and you're pretty comfortable with it, this homework should be a walk in the park. Should not be hard. However, if you hit the wall and you get flat forehead syndrome, come by and see me. I'll get you through it. Okay. It's more important that you learn it. Okay. All right. So on that note, let me go over to here and bring up some slides. Guess what happened? There's been other people that have been using Simpletron to teach assembler too. And what I did is I spent some time using our good friend Google and ChatGPT and Claude and Gemini and a bunch of other things to say, hey, I want to learn more about this. This is a pretty cool idea. It's not new. The original version is in C, how to program. I pulled it from a book, C++, how to program. It goes back about 10 years. Okay. So this is nothing new here. But I do want to strive to give you something that you can take with you for your future on what techniques and tips you need to do to land that job. Okay. And I will show you that after we get through this. Okay. So basically, this is explaining what it's doing. We have registers, we have flags, we have one accumulator, that's it. And the CPU contains one general purpose register. Memory is, there's 0 to 99, that's it. Okay. Before running a Simpletron machine, SML program, it must be loaded into memory. And if you've done this, you know it takes each step. And if you're tired of doing that, who would like a shortcut to have it, but take it in faster, so you don't have to type it in all the time? Yeah, everybody's hands should go up. I'll show you that trick later. Okay. All right. Each instruction occupies one word of memory, none of these double words or triple words or quad words or all that fancy stuff. And each location in the memory may contain either an instruction, a data value, or an unused area of memory. Okay. The Simpletron uses simple keyboard for the input, terminal for output. There it is. The ultimate Simpletron computer. I'll have you know that this is very similar to a computer that was all the rage in about 1979. MIC, I think. Maybe it had 2 I's in it. I don't remember. It was, they called it an MIC, but I think it's MS. But it's basically a box with a bunch of little levers on it. You flip the levers, you go, loads it into memory. Flip the memory, load your next one. And then you can do an ad, just like we're doing. Yay, we have gone back in time. Back to the future. Now, these are our opcodes. Notice there's a whole lot less here than what we have in our x86 instruction set. We have a read, a write, a load, a store, an add, and a subtract. And notice how the add and subtract says things, adds a word from a specific location in the memory to the word in the accumulator. It leaves the result in the accumulator. Same with subtract. Okay. And branch. And then branch one way, branch another. Okay. So here's our algorithm. Read A, read B, sum A and B, print sum, stop. Pretty straightforward. And if you can copy, cut, and paste, we can do this. But now I want to show you the shortcut. Okay. All right. So basically, these are the assembly instructions that we'll be doing. All right. So in this machine are what we would call, what do they call it? The assembly language and the machine language are a 1-to-1. That has not been that way since about 82, maybe 84. Your assembler today generally has one-to-many actual machine codes. There's some stuff that it gets, but that we have a generic assembler from GNU called GAS. And this generic assembler will take Fortran, COBOL, C, C++, whatever, and generate this generalized assembler that will work on different architecture. So you can take that generalized assembler and move it around and play with it, okay? All right, so basically in our example, we're using 7 instructions with locations 0 to 6, 3 values. Where do we put it? Homework, hint, blah, I give you the answers. So when we translate, It's giving you, how do we want to do this? Now, the way this code is written is, all right, we want to use 97, 98, 99 for our memory. Okay? Doesn't mean we have to. We could use 00 or 07, right? Because we have 0 to 99 for memory slots. Bring up the code that shows the answer to this on the website, you know, this one. And you can use the second one. It's actually the same answer. But notice it starts off with read, but then what's 09 mean?
Value?
That's the memory location. So in this case, they would say 2199, right? All right, branching. We'll stop at that one. Okay. So if we take our answer here, let me bring it over here. So we're taking 10. What does 10 say? Remember that from the macro? Mm-hmm. 10 is what? Read. Yeah. Everybody's gapping out on me here. I'm making your brain hurt. So I read a value, and what are the second digits? 09. The memory slot. And then we say 20, which is a right, and we put it in 09. You're beginning to see how this works now. The first two digits are telling it what to do, and the second two digits are telling it where to do it. Your lab will be add 3 numbers. Working code of adding 2 numbers. Is this a programming exercise? No. This is a logic exercise to see if you can think in the steps, add the step you need, and continue on. Programming is really nothing more than logic. You spend your life as a programmer doing 3 things: sequence, selection, and iteration. Sequence, step 1, step 2, step 3. Selection, red light stop, green light go. Iteration, I need to make 10 cups of coffee. For loop 1 to 10, make coffee. Okay. All right, now let me show you the shortcut on making this work. There's a couple ways we can do this. I'm going to copy this. We'll call that SML1. Okay, so I have a new file here. And what did I call it? Let me create a new file. New file. Let's call this SML1. And we can call it TXT. That's fine. And paste it in. So now how are we going to make this work? Well, if you've typed in one of the programs before, right? Everybody should have done that. You use plus 1009, but you don't need the read value, you don't need the 1, do you? Yeah. So we need to delete those, okay? So I need to delete these. Now, I don't know if column cut and paste supports, probably not. That would be too nice. Yeah, it's really hard to do column cut and paste where you draw down a column and pull it out in a text editor. Most people don't even bother. They just don't even put it in their editors. So basically you can do this, blah, 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 blah. Isn't that fun? And I'm using the same keys that you would use in Notepad, using the arrow keys and the N key. Now, to avoid our computer from dying, how do we exit the program? What do we have to type in?
Exit.
Yes, for the terminal and most other Unix commands. But in the Simpletron, how do we exit out of it?
Control C.
No. Negative 99999. That will give us the exit. Okay, we can leave it out, but we're going to put it in so I can show you how this does or does not behave. Okay, so I need to make sure it's saved. Do the Control S thing, and I'll close it and open a terminal. Waiting for it to refresh. Everybody working on it is using up some swap space. And let's see here. There it goes. LS. So there it is. So now what do I do? Well, there's a couple ways we can do this. Where's my mouse? Here we go. Careful, it's catching. All right. Yeah. Let's see here. I want to do this. I think it might be. I think that might be the easiest way to do it. So here's what I'd recommend. Now that we have our list of commands, right? So if I say cat SML1, highlight the commands. Copy them. Then do Simpletron, oops, /Simpletron. And then right click paste. Darn. Didn't work. It's asking for the integer. Oh no, that's right. That's the integer I want to enter. It's stuck. So let's look at this again. Okay. All right, all right. Now I'm gonna cheat here. Think this is what I did. Oops. I don't want to edit it. Well, I do want to edit it, so. Yeah,
Whenever I try to execute Simpletron, it says permission denied.
permission denied.
Yeah.
Are you in the right directory?
Yeah, I guess.
Did it, do you, when you do an LS, do you have 3 files?
Yeah.
And when you say /simpleton, what happens?
It says permission denied. So
Okay. I will help you in a second. Here's how I got it to work. I added a double space in there.
You save it into a file, right?
I think this is how I got it to work. Well, that was a little more than I wanted. Let's try that again.
Good to me. Professor, what's happening? No, what's happening with my computer screen?
You killed it.
That's what.
Oh, you're killing the machine. Oh no, the Jeremy box is gonna die. Ah.
It's just going infinite.
What you're in an endless loop. So you can close the terminal and it eventually time out. Yeah. It's you killed it.
So just Control C.
Now, in all honesty, I tested this through SSH in the terminal. I did not test it through the Jupyter Hub. So I did it a couple different ways. I'm on the wrong. That's not going to run on that computer.
Yeah, you just look at that.
No, I know, but what did I?
Oh, because
All right. Let's fix.
No, I don't like that at all.
Yeah, that's how I got it. Okay. Ta-da. Now. All right, I can make it work now. But let's fix your problem of permission denied. Figure it out? Why? Why not? I do a file.
I'm just, that's what I think it's the. Someone have to just.
Oh, it's-
Are you doing control C?
File didn't work for some reason.
Oh, you are.
I know.
So go back to the ASCII source, the CDT, take the G++ line. No. You just did G++. But you gotta be in the command. Miracles. All right. Who wants to know how this magic works? Kind of, sort of, maybe nobody? Yes, somebody?
I don't have that like work file.
G++. Yeah, you have to compile it. No, it's not there. So, type in history. You didn't compile it. G++? Say.
Are you supposed to see the results?
All right, now, so you have, when it comes to things like this, this is the world I lived in. Do I really have to type that again? If I had to type something 2, 3, 4 times, it was a prime candidate for automation. So I wouldn't have to type it again. So there's a couple ways we can do this, and I'll show you the easy one. Now I'm doing this through the SSH terminal, okay? And I'll just show you what the process is. It should behave itself through the Jupyter terminal, but I can't guarantee that it will, okay? All right. So what I do here, let me show you. I can't bring that over, I don't think. I might be able to. Let's see here. No. What this is doing is that this is the equivalent of copy, cut, and paste. Okay. So I'm using a command line to highlight, right click, copy. Okay. But this is what I'm actually copying. It's double spaced with no extra space after the 999. Okay. So I'm going to do the equivalent of copy, cut, and paste into my cut buffer. So there it is. So if I do Control Shift V now, let's do that. VI junk. You don't have to do this. I'm just showing you. And do Control Shift V. There's my stuff. So it's in my cut buffer. That's all I wanted to show you. So now, when I run Simpletron, it's in my cut buffer. Control Shift V, enter an integer, 9 and an 8. It shows me the accumulator, the instructions, it shows what's happening, and where the answer is somewhere. I have to scroll up to show you the answer. The answer is right here. Now, do you need to know the double spacing thing to solve this lab? No. But if you're lazy like me, you want to spend your time problem solving, not typing. So I'm giving you an option. Okay. So those the lab. Now the other lab is the equivalent of a for loop, and that shows up in the instructions. You can modify this one. And what is it? Print 1 to 10. So what are you going to modify? What numbers are you going to change to get your print of 1 to 10? So you're cheating on your for loop that you all did so well with. Okay. Now, you've logged into the Jeremy Lab 2 different ways. we repeated the compile from for the Simpletron. We did it once locally, and we've done it once on the machine that you can get to from anywhere on the planet. So you can SSH in or use the Jupyter Hub. Okay. So you can get to both machines. We talked briefly about the Simpletron and what you can do with it. And I want you to do 2 more pieces of code. And let me see if it works from here. I've got it still, it's still in my cut buffer. Doesn't look like it's going to work the same. So, well, let's do it this way. Cat SML1. Let me see. I bet you the Jupyter Hub. I'll place money on that. The Jupyter Hub uses the web browser cut buffer. The web browser cut buffer only has one option. The cut buffer on the system, I have as many as I set it to. So let's try that. Nope. Look at all that junk. I didn't put that in my cut buffer, did I? I didn't put all that in there. So there's something about the cut buffer that's all munged. So experiment. Okay. And on that note, there we go. What else do I want to do? Oh, couple more things. Before class, we were talking about, I do want to do some more stuff with assembler. I'll come back to that part at the end.
Sorry to interrupt, but the cut buffer does work. You didn't copy the -999. That's why I did that.
Oh, if you leave it out,
Yeah.
so leave out the .99 and it'll be.
No, I'm saying you left it out. That's why I did that.
Oh,
It did the
that's
same
why I
thing to
did.
me.
Okay, good catch. Let's see what happened. All right. I think what I'll do is I'll copy it this way. Actually copy the file rather than from the command line. Copy. Now go into the command line. Ah, Houston, well, kind of.
You have
Let's
to put
add
a negative.
99
You have to put-
numbers.
No, you have to put a negative.
Yeah, there's the -999. That's how you exit the program. So it didn't quite take.
No, you gotta put a negative integer for it to exit.
Oh, that didn't work. Well, when I did it from the other way, it didn't work. That means the minus isn't being kept in the cut buffer. Or do I need a return after that? Let's see here. Let's do cat into junk. Control Shift V, Control C.
I noticed that when you do the junk file, it puts it in a weird spot. So it looks like the -99 is a part of a different command, so it doesn't work.
Something about the -99 didn't get put into the cut buffer. Play with it. See if you can figure it out. It works fine from SSH. I can tell you that. That worked. That's interesting. So maybe I should, what I should do is this. Put some space, put one space under that, and then copy it that way.
I've done it that way. I've noticed it works. It just puts it in your next line of code. It's weird.
Yep, that works. Well, it's coming up with.
You need a negative. Once you put a negative, it stops and adds everything together. So you can.
Yeah, so there's something. Oh no, fatal error, accumulated overflow. So something about the copy, cut, and paste inside the Jupyter Hub is not working quite right. Okay. Caveat emptor, buyer beware. So let's show you how it works from SSH.
You can really just put as many things as you want in there, so long as it doesn't go above 99. Which is kind of funny. It defeats the point of needing to know stuff, because you get 3 numbers, because you can just put as many something as in there. Right?
That is not. And then even if you go over that, it won't take it.
Why is that the case? Oh, well, we'll do it that way. We'll do it this way. Careful, it's catching. Yeah, it does the same thing here. Well, caveat emptor. You'll have to tinker with it. Either that or just type it a bunch of times, which I'm sure you'll all just love. Okay. All right. Nothing like data entry, which is why my mouse is on the left side, because I did a ton of data entry in my life. It makes it much easier rather than hopping back and forth between keyboard and mouse. Okay. I wonder if we can modify the C++ program to take standard in and then just roll it. That'd be a really good fun. That'd be a fun assignment. Because how many have actually programmed a program that takes user input from the command line? 2 people. So when you type in command name, parameter, argv, argc, you didn't learn that in school, huh?
I did a little bit outside with a friend, but
You didn't learn that in school, did you? Yeah. argv and argc is not taught. You don't learn this. So I think it's important, but what do I know? Okay. We have the Jeremy Lab. You're logged in. You have this directory. And it has this file. And trust HTML. Just trust. So isn't that nice? Oh, you can't see it because it's the black on black. You all have your own web page out there now. You want to see your own web page? Let me show you how to see your own web page and how to change it. You'll have to follow this very precisely because basically I've cheating. When you have a web server, typically port 80 points and redirects traffic to 443. HTTP points to HTTPS. So if you're running Apache and you've got your main web page, it just pushes it over to HTTPS. Well, I don't do that. I've got a Apache web server running on HTTP and the Jupyter Hub running on HTTPS. So to explicitly load port 80, you have to type it in like this. jmkll.org:80. You must do that. And then you will do a slash. And then this is over there. Tilde. Whatever your login name is. So your F name, 1, 2, 3, 4, 5. And you can put a slash at the end. And it will bring up your default web page. or should.
Thank you for telling me that.
And if you refresh, it's going to go back to port 443 on HTTPS. Oh, that's right. That user doesn't work. This user might. Notice I hit refresh and I put in tilde Chuck, but it says hub. That means it's going to HTTPS. This is networking, web dev. So I have to type it again, http://jmkll.org/tilde/chuk/. All right, let me look. Let me see if Mr. Chuck has the right permissions.
I'm just wondering for the website, because I noticed that you don't need to log in if you just do the source, like if you just do the file, if you do the website to the user, then lab tree ASM, it goes straight to it if not asking you to log in.
Right. That's the point. It's stored the cache. Your password is in your local browser. So it thinks you want to go to the same website. Let's see what else is broken. I may have to pick this up next week. All right, let's see here. Let's see. 755.
Oh, is that what it is?
Yeah.
Never heard of it.
Dude, that's like something I thought about.
755. And that's the that should do its thing. See, it's going to the hub. It's well, plan B. I'll see if I can get this to behave for next week. If not, I may have to bind it to a different port, like port 88 or something. Something that's not well known. 80. Has anybody gotten it to work? You did?
Yeah.
Oh, is it working for you guys?
Yeah.
Well, that's good to know. I'm up here struggling away, floundering around, open mouth fish, oh, and you just let me drown. Well, how nice. I guess what's fair is fair, right? Ah, I just have to find the right user. Okay. This website is yours to do with whatever you want. So if you don't know anything about web and HTML5 or index or even what now is the time. You have been elected for the Computer Science Club to create a web page. Once you get a web page built, you can move it anywhere you want. Okay, it's hosting a web page is very simple. Okay, now there are tools that make website development much easier. And let me ask this question: in this room, how many have used or had exposure to Markdown? 1, 2, 3. Okay.
Wow.
This is what I'm trying to give you folks, is stuff that you're gonna get when you're out there. Okay. So this class is turning into, hey, you really need to know this. You want to see a scar on my back? Okay. So what I'm going to show you is something very simple. I'm not going to assign you a project on this because it's an assembler class. I do this in my Linux classes and some programming classes. But do a Google search on Markdown live editor. Pick one, I don't care. Whichever one comes up. Welcome, folks. This is how all documentation is now written. You write on the left and you run it through a script and you get what's on the right. Okay. This is Markdown. And if you want to have fun, do a Google search on static website generators and see how many you can find in your language of choice or not language of choice. When I do my websites on my website stuff, I'll bring up 273 again. I don't know if I demoed this or not, but this is all Markdown. I don't hand roll this HTML. What you have in your public HTML directory is pure HTML code. So you can actually edit HTML code in a text editor with all those pointy squirrely bracket thingies and have fun. That's fine. But you can also automate a lot of it. And this is how I do it. Let me move. I don't know if I demoed this or not. Maybe I did. I just went through it really fast. Well, I'll use this. Chrome and Brave allow you to run SSH as an add-in. No X Windows though, but that's all right. I'll go ahead and log in. And I've got a script, 273L, that brings up the main website. So let me bring up that right here. All right. I'm going to add a date right there. That's all I'm going to do. So what am I using? I'm using VI, my favorite editor. And I'm simply going to add a link for tonight. And 10th, right? Been a long day. I started today in Colorado Springs. Now I save the file and then I run a script that builds everything for me. And I do refresh once that's done. There's my new date. Or would you rather edit by hand all this, view page source, that? Doesn't that look fun? If you've never used view page source, start using it. It shows you all kinds of nefarious things that is sitting back to the mothership. The Microsoft Outlook web app has over 2,000 third-party cookies. Is that crazy or what? I have nothing to hide. Well, you couldn't hide if you wanted to.
Yeah, exactly.
Okay. So, all right. That's what Markdown is about. It's for documentation on GitHub. All the documentation is written in Markdown and it renders it for you. GitHub Pages is a place to do a free website, which I would recommend for the computer club. They should all know GitHub anyway. And is Gabriel still around in the area? No, he moved? No. Pardon?
I have no idea. I haven't been to the club this semester.
Yeah, is he even in the area?
I have no idea.
Okay,
I
I've
did
lost
not
touch with him, but Gabriel was in the club last year. He was the on-site GitHub guru. And he would teach anybody everything they needed to know about GitHub. So if he comes around again, I'll ask him if he wants to show up and ask, okay? So if you don't know GitHub, that's one of the things you need to know. That's a job thing. Your company might use BitLocker or something else, but it's all variations on a theme, and GitHub is free for you guys. So,
Yeah.
all right, so you have 15 minutes to play and ask questions. I would highly recommend taking the 15 minutes and redoing some of the things we did so it doesn't leak out. If you only touch this class once a week, that's fine. You'll probably get an A, but you won't get the job. Okay. All right. I keep hashing on that. I sound like a grump, but sorry, truth.
I was just wondering, is there a way to see Chrome's source code? Like not like the website, but just like Google Chrome, the app's source code.
View page source.
No,
Right.
not the page source, but like Google Chrome, the app is source. Like how do you check it? The source of different apps from like the Zoom app to GeForce Experience app.
Oh. What you're asking about is the developer tools.
Oh, so it is like.
That is a discussion for an entire 5-day seminar at Google. Google Chrome is basically its own operating system. And if you want to dig into the covers to start with, use the developer tools, and you can see how much network your web page is using at Zoom, or the sources of where all this stuff is coming from. Like when you run, how many different apps or how many different fonts are downloaded off Google to render your web page. All that is being collected and put into a big giant data harvesting thing. One of the things I thought was really interesting listening to the developers of Chrome, they said, yeah, we weren't sure if this JavaScript function was being used in the right way. So we polled our users, 14 million at the time, behind the scenes while the users didn't know, to see if they were optimizing that function or not. Pretty amazing stuff. I can make you all paranoid, but that's not the point. The developer tools lead you to all sorts of interesting. This is not for the faint of heart. This is, if you're a full stack web developer, you'll be spending a lot of time in there. Okay. This is JavaScript, your Vue.js, and or your Angular and your JS, and then your back database, MongoDB, Firebase, whatever, and you'll be doing all that. Probably in a Docker container somewhere. Okay. All right. So have fun and play. And I will stop the recording and the share. So cheers, Tash.
Have a good day.